Alright, so here's the final pass-off for Lab 11. This is the UART Receiver module. You can see we've got the FPGA set up right here. I'll just explain the way the LEDs are set up. These bottom 8 LEDs right here are representing the received ASCII character, just those 8 bits of received data. And then this topmost LED is the receive signal. So when we receive a new ASCII character, that will come on until I press the button to send the received signal high and complete that handshake part. And then this LED 2 spaces over, just to differentiate them a little bit better, is the parity error LED. You'll notice that it's high right now, which is just because the shift register is all zeros. So the current bit has technically an even number of ones in it, and so that gives it a parity error. And then this center button right here is what we'll use to send the received signal high, so that acknowledgement of the handshake. And then this up button will be the global reset for this circuit. So I have a few characters here and their expected values, so we can try a few of those out. You can see we have PuTTY loaded up right here to handle the serial communication. So we'll start with this semicolon right here. If we put that in, you'll see we'll get this 00111011. It shows up the same as it does on the LED, and you also see this receive LED goes high until we hit this center button. That'll go low. The parity error LED has also gone low, since it's doing what it should. It's flipping that parity bit depending on how the bits are. And then we can try a few other characters. We put this dash. You can see we get the correct one for that. Send that receive signal again. We've got this uppercase H. Because of the way ASCII characters are spaced out, you'll see these first 4, or the last 4 digits won't change between the uppercase and lowercase h, but the first 4 will change. So if we send that receive and then send a lowercase h, you'll see the first, I guess, hex digit will increment by 2. The next one will stay the same, since that's just the way the ASCII table is set up. We can do the same thing with, let's say, uppercase R and a lowercase r. See that example, and then we can also test the reset just to make sure that works. That reset sets the shift register back to 0, and we'll get that 0 output, and that parity bit will go back high, or the parity error will go back high, since we're technically getting an even output. We can test it with a couple digits as well. Let's give it a 2, which will be a hex 3-2. Can receive that, and then an 8, which will give us a hex 3-8. And send the receive on that, and we can reset. And also see if we close out of this instance, and we open another PuTTY session, but this time using even parity for the serial. We reset. Let's try some of these characters again. Let's try sending that semicolon. You'll see we're getting this same output as before, and we can hit that to send the receive low, but we are getting a parity error because the FPGA is programmed for odd parity, but the PuTTY is sending its parity bits so that it will set up even parity. We can try this with a couple other characters, like that dash like we had before. You can see for all of these, that parity error light is staying high, since it's using a different parity on PuTTY's end than it is on the FPGA end. That should be all the demonstrations for this lab. There you go.